The only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4, 3, 2, 1.
Hello everybody, I'm Stuart Valco, and welcome to this episode of Into the Impossible Innovator Series. Private space flight is booming, and today we're going to talk to a company right in the middle of it that was born right here at University of California, San Diego, the Additive Rocket Corporation. They're disrupting spaceflight through unique design and manufacturing methodology for rocket engines. We're going to talk to two of their founders, and we're going to see just what makes them innovators. Hello everybody, welcome to Into the Impossible. In this episode on innovation, we're going to be talking to two of the co-founders of Additive Rocket Corporation. I'd first like to introduce Reiley Weeks. Hello Reiley.
Hi. As Stuart said, my name is Reiley Weeks. I'm the Chief Science Officer of the Additive Rocket Corporation. I'm a former Northrop Grumman engineer and am currently working on my PhD here at UC San Diego.
And we have Kyle Adriani. Kyle, tell us a little bit about yourself. You're the Chief Technology Officer.
That's right. Kyle Adriani, CTO, co-founder of ARC. Got my BS in physics, materials physics from here at UCSD as well.
So why don't I start with Reiley? Tell us, how did this company come about? How did you come up with the idea?
That's a great question. It all started when we were originally members of the on-campus group at UC San Diego, SEDS, where we took part in the first ever 3D printed rocket engine produced by a college group. And in working through that, we ended up meeting a lot of industry who were interested in the technology and the innovation that went into 3D printing an engine. And we started having more ideas of where we could take the engine tech from sort of this traditional idea to something no one has ever seen before. And that's kind of how we got our start.
And Kyle, how did you get involved?
So I founded the company, of course, with Reiley, and one of our other co-founders, Andy Kitiwong, was actually my roommate. We were randomly paired up. We knew we were going to get into trouble somehow and do something. We didn't know it would be this bad. So we were working together in clubs and all sorts of things, and then we decided to start this out.
So so what essentially you're doing is you're disrupting an entire industry, and you found a way to essentially manufacture rocket engines in a new innovative way that could, I suppose, say, disrupt the entire industry of how they're made today. So Reiley, tell us a little bit about that. What is it that you've innovated here?
So, interestingly enough, the 3D printing itself is not necessarily the innovation. There's a couple other companies out there who are doing the actual 3D printing aspect. SpaceX 3D prints portions or entire engines. Rocket Lab also prints their engines, and there's a couple other companies who are doing the printing aspect. Where we innovate is in leveraging new designs that the 3D printing makes available to us. These other companies that are 3D printing, they're sticking with the traditional ideas. For instance, there's a SpaceX engine that is almost directly from the Apollo era, almost the exact same design, they're just 3D printing it now. Whereas we have seen that 3D printing allows us to take much more organic and free approaches to how we design our engines, and so we're leveraging that to produce lower costs, more efficient, and overall just better engines for the space industry.
So here's a photo of one of your engines. Can you tell us a little bit about it?
Absolutely. So this is our flagship engine. It's the Nemesis Engine is what we called it, named because it was a real pain to get going, but we got there. So what the photo doesn't necessarily show is what's going on the inside. The outside is more or less standard. There's definitely some features that are only really 3D printable, mainly that it's a single piece engine, which was brand new when we first developed this. But inside we have passages and cooling channels, fluid delivery systems that are only possible with 3D printing. They leverage a biomimetic approach and course through the engine, similar to how blood vessels course through the body or how tree roots course through the earth. There's a various biological analogies one could use. And we found that these biomimetic geometries are more efficient and generally better in the situations that we put them in.
So maybe I'll ask Kyle about this one. So here's another image of what might be kind of your biomimetic.
Right.
It almost looks like a capillary system.
That's right. That's right. So all of these are more showcase projects to just show how far you can take this additive manufacturing. Like Reiley said, we get a couple more areas of design freedom that we can leverage when we're designing a part for additive manufacturing, which is exactly what we have done for that, which was a heat exchanger as well as the engine shown previously.
Just for scale, I do have an image of it in the hand here, so you can kind of see that heat exchanger. It's exquisitely, some parts of it are exquisitely fine.
Right, right. It's both complex and simple at the same time. So it's the basis for those sorts of geometries they're modeled after fractals, much as much of the body, like capillaries are. This one in particular kind of mimics that heat exchange that you would see just like chemical exchange, oxygen exchange via capillaries, or heat exchange in other organisms. Salmon, sharks come to mind as well.
Here's one that's you can see this is the bottom.
That's the top.
This is the top. Okay.
Yeah, that's the injector portion of one of our more recent concept engines.
And describe this a little bit. What's it? What am I looking at?
So you're looking at around the outside mounting points, and then on the inside some channels branching out in a very specific pattern to plumb up an engine for injection. And
so tell us a little bit more about the your role and the I mean, part of the technology here that you're refining or perfecting is how you use the manufacturing techniques.
That's right. That's right. So the additive manufacturing techniques, there are a bunch, and some of them have been around longer than others and have different levels of maturity and capability. The big one that's really reached the become industry standard here and has been adopted by a lot of companies to various degrees of success has been direct metal laser sintering, a powder bed additive manufacturing method where all your parts are completely encased in powder. 20 to 40 micron layers of powder laid down one after another, and each cross section is traced out by a laser system above, much like this system you're seeing here. And so that allows us to, it takes quite a bit of time, but we can build up extraordinarily complex parts that you couldn't make any other way, are very difficult to design in and of themselves. Reiley knows better than anybody, but also unlock some huge performance benefits, massive reductions in weight, improved heat transfer capability, lower head loss for fluid systems, more control over really all those values, more specific and dialed in capability.
I recently got to see it myself, and here you can see a picture of me. My jaw is dropping as I'm watching this thing work. It looks like it's just magic how the machine, the laser beams, lay down the layers. It's fusing these tiny spheres.
That's right.
Yep.
And that's called laser scintillation, correct?
Sintering, yeah.
Sintering.
Yeah, which is a little bit of a misnomer. It is melting. They're used interchangeably in this industry as opposed to what is typically considered sintering. But yeah, it's melting. It's taking powder, melting, fusing it together to get a nearly fully dense part.
So tell us a little bit about where the company is at now, and you've been in business a few years, three years.
About 3.
And what's the status of it?
Yeah, so we're we're growing. We've turned over kind of the leaf from being purely on the R&D side, which we were for about a year and a half at the outstart, to of course bring in that industry standard metal printer, really building up our capabilities and making revenue, which is of course rare for startups.
Yeah, almost reaching hitting the black in terms
we're
of
close.
actually turning a profit.
We're really close,
which is pretty huge.
And so you got some news recently. I guess you've done a couple of test firings of the rocket. And I guess here's a shot of a static firing of your current model. So what's going on here?
So right there, that was one of those showcase engines that we showed prior, and we're really just putting it through its paces and also running it outside of standard operating conditions, higher pressure, off of the ideal mixture ratio in both directions for the fuel and the oxidizer. And one of the big things we really wanted to see out of this was just how well-performing our cooling systems would be. So across all of those tests, on the outside of the engine at the hottest point where we expected to hit probably like 500 or 600 C.
At least.
We didn't get above 170, right?
176.
176 C was our max temperature. So we were very, very pleased with that performance. We were glad that our conservative estimates stacked up in the right way to help us out. But what that really means for us, one is we have really a new baseline, not only that we can leverage for customers that we're working with on designs, but also information we can make available to our customers so that they know we can reduce weight dramatically, improve performance of thermal systems, and all around push these parts to the next level. So that's what we're really excited about.
In case people want to see that, there's I think that's different. Is that the same model?
No, that's the most recent one. So that, when you're holding it there, had just come out of the printer, I think 2 days prior.
Yep.
So you can see how big it is. It's not very big.
No.
It's very compact.
Packs a punch.
Oh, yeah.
And this one has a pattern, a grid, sort of a spiral grid pattern.
That's right.
So is that part of the cooling?
That's part of the cooling, and the reason that you see that exposed, that's atypical. It's exposed just because we're carving out every little bit of weight that we possibly can out of the engine. Where most of those features that you see would just kind of be encased in material. It, much like that engine and others, you can't really see too much of them. we've really stripped away all that excess material.
So this shot was one, maybe it's a prior version that doesn't have that taken away.
Yep.
And I think you said it was 2,000 pounds of thrust in that little thing?
In the other one you were holding, yeah.
Yeah.
That,
you're holding about 2,000.
that is an impressive wallop for that. And no moving parts, right?
No moving parts.
No.
You may put a pump or some other systems upstream of this. Some of that, we have comfort zone with some components where we typically don't touch too much of, but we're doing some work with an increasing number of those additional upstream systems. The engines are really the last step in the process. We saw that as a good place to, one, make a mark, and two, that was really ready for a bunch of optimization.
And that's not all you make. You showed me a bunch of other parts.
That's right.
Which is kind of part of your business, right?
Yeah, absolutely. So we act not only as a design and manufacturing group, but it's really the very high end parts where you need it to come out just so, where we really excel. So a good number of our customers have said, "Hey, this thing you made for me is great. Can you also make this? Can you also make that?" And of course, like most young and ambitious guys, we have trouble saying no. Yeah. So we do them, and we found that we do a pretty good job, and we do it. We found that we've been very successful at that, and doing it in a quick turn fashion.
So I guess I'll address this to you, because you're more the scientist in the team. We happen to be doing this on, as you pointed out, the 50th anniversary of the Apollo launch, Apollo 11 launch. And it's interesting that rocket motors haven't changed that much, right? I mean, it's just a matter of scale. This is kind of a major leap. So what's the science behind what you're doing to get to the next level of spaceflight?
That's a great question. It all roots in basically the next level of simulation capabilities that we have. So in the original Apollo era and rockets and of that time, they were doing things through basic experimentation. So they found something that worked and they stuck with it, and that's what we've stuck with. And the basics of how a rocket engine works are pretty much never going to change, right? It's all the fundamentals are going to be there. It's how we get to those fundamental stages that's going to change. And so with new computational resources, new simulation capabilities, it allows us to do these most minute of changes and tweaks to see if we can squeeze just a little bit more performance out of it that we've leveraged to create these models. And then 3D printing allows us to create them.
Right. So these sorts of engines, just to go off of Reiley's point, are very sensitive to the smallest little design tweaks, have a huge impact. And so we not only have control of them in the design and via manufacturing, but we can also simulate their effects leveraging cloud and supercomputing to rapidly iterate through thousands of possibilities.
We're kind of going through a renaissance of space flight because of private space industry, especially everyone knows SpaceX. There's a couple other companies, maybe you could mention them. Are those your customers? What do you think is the future look like? The near future, and maybe 5 to 10 years out.
Right. Well, we won't talk about any of our customers specifically and what they are doing, because they wouldn't appreciate that. But if we're talking about the commercial small launch industry, there was just an explosion over the past 2 years, where 2 to 3, where it went from SpaceX and Blue Origin and Rocket Lab and a couple others too. I think it hit at the peak 116 small startups saying they're making launch vehicles and raising money, and some of them raised a tremendous amount of money to do that.
Yeah.
Since then, it's been enough time for a couple of those to fizzle off, but I think more than anybody expected have stuck around.
Yep.
And they're going along with various degrees of success, exploring a lot of different business models and launch strategies around those. Everything from traditional, what you think of, what SpaceX does, staged launch, their unique aspect is reusability, to groups trying to do single stage to orbit, to taking an atmospheric balloon and launching out of that, to piggybacking off hypersonic vehicles, which are kind of dovetailing with the whole industry as well. So we're seeing those wide range of applications. Sea launch as well.
Yeah, sea launch. That's
is another one, and
interesting.
That's an area where we found that we fit in well, because whereas groups where they're really just doing the traditional launch, that's already a lot of those problems have already been solved. They're trying to do it more efficiently. So the engines are their biggest element, and so it makes sense for them to do those themselves. Other groups where they're revolutionizing in 10 other ways the launch process, the engines are not necessarily where they want to be spending their time and resources, and they prefer to go to a group that has really an expertise in manufacturing those components, or taking what they have and optimizing it for manufacturing, which is oftentimes the case of where we fit in.
So what is next? Where are you? What are you planning? What are you scheming and planning?
We can't tell you that.
That's a good question. Short term, we're actually looking to begin expanding into a new facility in the next maybe 6 months or so. We're hoping for end of Q4, beginning of Q1
Ideally
next year.
Before the end of the year, we'll try.
Yeah. And when we move there, we're planning to bring in more machines, more additive machines, as well as some subtractive machines for finishing and stuff like that. But the biggest thing is we're trying to add on more and more customers in the aerospace industry, design more and more engines, and that's going to be longer term, mostly because each one of those contracts is going to be like 6 months long.
That's right.
But that's the basic overview of where we're going. Continue to vet out our technology and possibly come up with some new interesting things to add into rocket engines. But yeah, that's kind of where we're headed.
And what do both of you think about the the future of you discussed this incredible explosion of private space. A lot of people are talking about we're going to go back to the moon is a major point of discussion. Should we go back? Why are we going back? And other people are talking more about the SpaceX launch of 1,000 microsats.
Right.
We talk about Cube Labs.
Right.
There's a Cube Lab going up. The Clark Center is involved in the BORD mission, which is launching in a couple of days to the International Space Station. The Brain Organoid Advanced Research and Development Project. What do you guys think? Are you going to start looking at bigger engines? Are your engines designed for more satellite kind of things? And where do you think space is headed in general?
So I'd lump it into a couple of categories. You mentioned some research-based items, which are all very exciting, and you also have the more exploration-based to Mars, and really the human proliferation of either another in-space habitat or expanding in-space habitats, or colonizing the moon, Mars, all of that. Then you have asteroid mining type missions, and you have more immediate and applicable to our everyday lives, constellations that are providing necessary and very valuable services back to everybody on the planet.
And Reiley, do you have any other thoughts on that?
I mean, from a business perspective, in terms of how we fit into each of these different groups, we think we found the thrusters that most people are interested in. Personally, I want to build the biggest one we possibly can. I want to make the F1 look like a child's toy. Probably not really feasible in the near future.
Tell us what the F1 is.
The F1 is one of the 5 main engines on the Saturn V that carried the Apollo program to the moon. Notable for being the largest and most powerful single combustion chamber engine ever produced. I believe it produced about 1.5 million pounds of thrust. Compare that to our current engines that are all around the 1,000 to 5,000 pound force thrust range. So it's a little bigger, but I want to go even bigger, make them huge.
Any closing thoughts, or do you want to mention about ARC or your journey? I mean, both of you came out of UCSD, and
Yeah.
You got involved in the startup scene here, and how did you end up at the Qualcomm innovation space, and what was your experience like?
Right. When we were starting, there was one rocket club on campus. Now there are 3.
Yeah.
And there was one graduate and faculty-based startup incubator type thing. Since then, I think there have been almost 6 that have existed just on this campus alone. We've seen that trend mimicked across the country at big and small universities as well, of really a lot of some of the most capable students going into startups, as opposed to other pursuits where they feel they can make the biggest difference in the world most immediately by taking this path. It's not an easy path. It's very, very hard. A lot of sleepless nights, but a lot of fun.
Any advice for other students that want to get into business of space?
Yeah. So there are a tremendous number of resources, and there are also many, many ways that you can do it. We went down kind of a venture financing route, which is one way to do it that has pros and cons. Other groups choose more traditional grant funding or smaller scale investing, depending on what their goal is and how quickly they need to accomplish it to be successful. So really, really knowing that, and just the canonical advice that everybody would give is if you're making a business, you're going to have a customer. And you want to talk to as many of those potential customers as you can, as early as you can, because even when we were starting, we had a different idea about how it would work out than it did along the way. It's been at times just a random walk to where we've ended up, and making it taking away as much randomness as you can will, of course, help you get there faster.
Yeah, kind of taking off from what Kyle said is, if you have an idea, don't be afraid to let it change as you try and build something. Just because you might find out that your particular idea of how the world works or how you want space to be may not be something that everyone else is on board with. So you may need to tweak it, shift it, do something to finally get something that people are looking for.
I want to thank both of you for being with us today on Into the Impossible from the Arthur C. Clarke Center for Human Imagination here at the University of California, San Diego.
The only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4, 3, 2,